Okay, YouTube, we've been discussing angles and standard position. And in this video, what we're going to do is we're going to introduce the concept of what we refer to as a reference angle, or sometimes you'll see these referred to as a related angle. And so that is to say that every angle in standard position is going to have some reference angle associated with it. And we want to kind of find out what the heck a reference angle is. And so when it comes to at least evaluating trig functions greater than 90 degrees and at least all negative angles, what we're going to do is we're going to make use of what we refer to as a reference angle. And the nice thing about it is that it is a positive and acute angle. So this positive acute angle, the reference angle, let's define it thusly. So we say let theta be a non-acute angle in standard position that lies in a quadrant. So what I'm going to do is I'm going to kind of put a hypothetical out here. If we were to say that we had some non-acute angle, it would have to start over here in standard position on the positive x-axis, but it would have to go somewhere outside of this first quadrant here. So maybe something like this. And we could say that our angle here in this particular instance is this angle, and we're referring to it as theta. So given that this matches this description, we would say that its reference angle is the positive acute angle, and we refer to this as theta prime. That's how you read this value here, theta with the apostrophe. So it's the positive acute angle theta prime, and it's formed by the terminal side of theta in the x-axis. So what I'm going to do is I'm going to pull out a different color here, but basically what we're saying is if you had some angle theta in standard position, then if you were to mentally highlight, okay, the terminal side, which is this side right here, and then the x-axis, it is the acute angle formed between the terminal side of the original angle and the x-axis. Now you'll notice that there are two angles formed here, one there and one there. We say, well, which one is it, the single arc or the double arc that I drew here? And it's the double. And the reason why is because we said that reference angles must always be acute angles. And so what we're going to do is we're going to label this right here as theta prime. But essentially what we're seeing is given any angle, if we were to take from the terminal side back to the x-axis and look at that acute angle, we would have some reference angle theta prime. So looking at these other diagrams here, we would say that what if theta had terminated in the third quadrant? Where would its reference angle be? And so we could see that its terminal side is here, the x-axis is here, and so its reference angle is this theta prime that lies between them. And then last but not least, if we had an angle that spun around to the fourth quadrant, starts here, ends here, then we'd say the terminal side and the x-axis are here and here, so its reference angle is this positive angle that is acute and is located here. So our job a lot of the time is going to be to discover what is the reference angle for a given angle. So now the only diagram that you did not see drawn here was what if our angle terminates in the first quadrant. And so the interesting thing about this is we say, well, this is the angle theta, but it's also theta prime, because between the terminal side and the x-axis would be this original angle that we started with in the first place. Okay, so what you're seeing down here are essentially, these are just kind of like keys. What I guess I mean to say here is this. We say if our angle is between 90 and 180 degrees, that is to say if we had had an initial standard position angle theta that terminated in the second quadrant, then we say that the reference angle theta prime is equal to 180 degrees minus the original angle theta. So what I kind of want to point out here is this, kind of on the next slide here, we're going to be finding reference angles, but let me go ahead and pick on a particular angle that I happen to know lies in the second quadrant. So when we look at this and we say, well, 120 degrees, first of all, where would that lie? Well, it would start on the positive x, it would go past 90, as a matter of fact, it would go 30 degrees past 90. So it would look maybe something like this right here, and we can go ahead and label this as theta, and our theta is equal to 120 degrees. So the first thing we want to do is identify, well, then where would the reference angle be? Now the reference angle is always between the terminal side, so here's our terminal side of this angle, and then the x-axis such that it makes it an acute angle. So I would say just right here, and we'd say that this angle right here, this would be our theta prime. And in terms of what we get, now going back and looking at my key, what you can see is that it's really saying that in our particular case, since our angle is in the third or the second quadrant, then theta prime would be equal to this 180 degrees, which would be a full rotation all the way across here. And what we're doing is we're subtracting off this initial 120, which leaves behind this questionable rotation right there. And so what we're saying is that our theta prime would be equal to 180 degrees minus our initial angle of 120 degrees, and in this particular case we just get left with 60 degrees right here. I'm actually a big advocate for, well, if you just go sketch this in the first place, you could probably figure out the reference angle without having to do all of these different methods depending upon where you terminated. That's just too much information to memorize. So with these right here, what we're going to do is sketch them, and we're also going to look at what their reference angles are, starting with our 210 degree angle. So I would say that the reference angle for a 210 degree angle, theta prime, we'll start by sketching a 210. Now what we know about a 210 degree angle, our 210 degree angle would be at least 180 degrees plus another 30. So we would be somewhere over in the third quadrant here. Oops, keep hitting the wrong key here. So we would say that this is our 210 right here. So in order to find the reference angle, we'd say between the terminal side of this angle and the x-axis, it would just be this angle right here. And so in this particular case, it's pretty easy to identify that we would get 30 degrees as our reference angle. So another way to look at this is we could have said, let's take our initial 270 degree rotation and take off 210 of those degrees. Actually, that would leave us behind with this part right here. What we would want to do is take 210, which is our angle theta here, and subtract off this initial 180 degree rotation, leaving behind just this part right here. So we would say 210 minus 180 leaves us to 30. Again, I think it's just easier to indicate this by visually doing this. So let's go ahead and take a look at our 7 pi fourths. Now, pi fourths. Remember that pi fourths, if we're going to look at this, we know that half a rotation is pi and that a full rotation is 2 pi. If we're going to convert these to fourths, this would be the same thing as 4 pi fourths over here, and this would be the same thing as 8 pi fourths over here. So 7 pi fourths, this is really like saying we have, let's see, pi fourths, 2 pi fourths, 3 pi fourths, 4 pi fourths, 5 pi fourths, 6 pi fourths, 7 pi fourths. So our 7 pi fourths radian measurement comes over to here. We say that this is 7 pi fourths. The question becomes, well then what's the reference angle? So I'll switch my colors up again here. We'll go over to like a brown, but we'd say here's my terminal side, and here's the x-axis. So my reference angle is this angle right here, and the nice thing about it is because these are all pi fourths, we can see that this is just a leftover pi fourth right here, and that's an acute angle and it's positive, okay? So taking a look at a negative angle here, negative 240. 240, negative just means that we'll rotate clockwise, and so we would say this is negative 180 degrees right here, this is negative 270 degrees right here. By using our quadrantal angles, we could say that 240 is like 60 degrees past a negative 180, or at least 30 degrees shy of 270. So here is our angle that represents a negative 240 degree angle. So our reference angle, let's go ahead and take a look at it. The reference angle would have to lie between the terminal side and the x-axis. And so because we're looking for this right here, and because this is negative 240 that we listed right here, we could say that I suppose that's 60 degrees past this negative 180 that we had right here, and also 30 degrees shy of this right here. So we'd say that our theta prime, suppose we should list this up here, theta prime is 60. Over here we found theta prime was equal to a pi fourth. Here theta prime was equal to 30 degrees. So now my favorite, this 3.6. We say, well, what the heck is 3.6? Well, it's not degrees. See, the thing is, we know that in a standard set of rotations with radian measurement, we know that this is a pi radian rotation and this is 2 pi. As a matter of fact, I'm going to write that this is pi halves and that this is 3 pi halves. And the reason why is because I'm just going to convert some of these to decimals. As a matter of fact, I say that this is 3.14, this is 6.28. I know that half of pi is about 1.57, and this is about 4 point something down here. I'm not going to chase after. I think it's 4.71. But the idea is that if you're going to sketch a 3.6 radian measurement, then what I know is that it would have to be slightly beyond 3.14. And so I would say that this is my angle right here. We'll say this is theta, and this is 3.6. And in order to find this leftover part right here, what we're going to do is we're going to take that entire 3.6. We say theta prime is equal to our initial 3.6 radians, and we're going to subtract off 1 pi's worth of radians rotation. That is to say, if I have this total blue rotation, and I just want this brown part right there, we'll take the full thing, and we'll subtract off this blue part that you see right here, and we'll be left behind with this leftover portion. So roughly, we would get about 3.60 minus 3.14. Looks like we would get, oops, 0. This would be a 4.6. And so we would say that our reference angle here is about 0.46 radians.